One of the things you can do with matrix inverses is you can use them to solve a matrix equation like this. You can see we have a matrix times a matrix equals a matrix, so this is why it's a matrix equation. I'm going to go ahead and call this first matrix capital A. This one right here, it's a very common thing to use a capital X when you have a matrix of just variables like that. And I'm going to call this matrix B, capital B. So if I wanted to solve this, well, if this was real numbers, if I had something like 3x equals 4, what I'd want to do is I'd want to divide both sides by 3, right? I'd get x equals 4/3. That's easy enough. But there is no division. The reason there's no division here is because, well, we have something similar to division. We have matrix inverses. And right now I have AX equals B. And the matrix inverse that I'm after here, well, I'm trying to figure out, I have a variable matrix here, X. That's the thing I'm trying to kind of isolate. And so that means I'd like to get rid of this capital A. And with matrix inverses, I might very well have an A inverse that I can, well, I'm going to try it. I'm going to say, okay, let's just refer to A inverse. Yeah, I'm just going to put it in here. I'm going to say A inverse over here on the left. Because if I multiply on the left by A inverse, what's going to happen is I can put parentheses around that. There's still an associative property and a distributive property when we're dealing with, well, a limited distributive property. Oh no, I'm not sure. Whatever. There's an associative property. That's the important thing. Meaning I can put parentheses around the A inverse times A. But I multiplied by A inverse on the left over here, which means I also have to multiply by A inverse on the left over here. You'll notice that if I multiply by A inverse on the right, if I had AX times A inverse equals B times A inverse, remember that this is not commutative. I can't just swap the direction of these things. So X times A inverse actually doesn't exist, because this is a 2×1 matrix, this is a 2×2 matrix. So this would not even exist. And similarly, this is a 2×1 matrix, and this is a 2×2 matrix. That one wouldn't exist either. So we can't multiply by A inverse on the right, or at least it wouldn't do us any good. Instead, I would multiply by A inverse on the left over here, multiply by A inverse on the left over here. Over here, the reason I'm doing that is because we get an identity. The inverse times a matrix gives us the identity. And over here, that's A inverse, or I times X. And over here, this is the thing we're actually looking for, because this ultimately on the left here is just X. So in this instance, if I wanted to solve this matrix, this matrix equation, what I can do is I can just say, okay, well, I'm going to call this one A, so I'm going to put that into my calculator. Oops. Edit to -315. You can see it's already in there. And then we'll do this one. This is a 2×1 matrix. 4, enter 2, enter. Typing with my mouse here. Alright, I'll hit second quit, and let's go, I want to do A inverse times B, so I'm going to go back into matrix, I'm going to go A, you can see that's what's selected up here, press enter, and do inverse, and if you're doing this on the TI-36X Pro, remember you hit your, go into exponent and then just type in -1 for your exponent, and then I'm going to do B, matrix B here. A inverse times B gives us 2, 0. So that means this matrix, the capital X, which was lowercase x, lowercase y, is equal to the matrix 2, 0. So that means x equals 2 and y equals 0. So we could do that same sort of thing down here. And we don't need to kind of go through nearly as many steps here, because I just did, well, the exact same thing. AX equals B. If I want to figure out what X is, this is going to be A inverse times B. And I can just type that in. So let's see, I'll first go ahead and edit my matrix here. This is 5, 4, 4, negative 3. And matrix B looks like this, 23, 6. And I've already typed in A inverse B, so I could just press enter to have it reevaluate that, or I could do second and then enter to have it pop it up again and then reevaluate it. In either of those cases, you can see I get 3, 2. So x is equal to 3, 2. Remember, this was the matrix little x, little y. So that means x is 3 and little x is 3, little y is 2.